Good day, everyone. I welcome you to another edition of Mathematics with Alimi Abdulhakim. We have this question from Pearson Edexcel Paper 1, 2024. The question says, the first three terms of a geometric sequence are 3 raised to the power of 4k minus 5, 9 raised to the power of 7 minus 2k, and 3 raised to the power 2 open bracket k minus 1 close bracket, where k is a constant. A. Using algebra and making your reasoning clear, prove that k equals to 5 over 2. B. Hence, find the sum to infinity of the geometric sequence. So for this question now, what do we do here? Quite easy. We can start solving by writing out the sequence. What are the sequence? The first one is what? 3 raised to power what? 4k minus 5, comma, 9 raised to power what? 7 minus 2k, comma, 3 raised to power 2 open bracket k minus 1. We are going to recall, we'll recall that under geometric sequence, that if I want to get the common difference, my common difference is equal to what? T2 over what? T1 is equal to what? T3 over T2. And if you look at what we have here, this is my what? This is my T1, this is my T2, and this is my T3. Applying what we have here now, what do we have here now? I'll be having this as what? 3 raised to the power, 9, not 3, 9. This will be 9. That's T2. 9 raised to the power what? 7 minus 2k over 3 raised to the power what? 4k minus 5 is equals to what? 3 raised to the power what? 2 open brackets k minus 1 over 9 raised to the power what? 7 minus 2k. If you look at it now, all the base there, they are all multiples of 3, both 3 and 9. But I want everything to have equal base. That means to be in 3s. So I can write this to become 3 raised to the power what? 2 open bracket 7 minus 2k over 3 raised to the power what? 4k minus 5 is equals to what? 3 raised to the power what? 2k minus 2 over 3 raised to the power what? Open bracket what? 7 minus 2k. If I'm to expand my bracket, that will become 3 raised to the power what? 14 minus 4k over 3 raised to the power what? 4k minus 5 equals to 3 raised to the power what? 2k minus 2 over 3 raised to the power what? 14 minus 4k. If I'm to solve this further, we'll be applying what? Let me apply the second law of indices. Applying the second law of indices. We state a raised to power m over a raised to power n is equals to a raised to power what? M minus n. To both sides. So if I'm to apply that, that will become 3 raised to power what? 14 minus 4k minus open bracket 4k minus 5 is equals to what? 3 raised to power what? 2k minus 2 minus 14 minus 4k. If I'm to solve this further, that will become 3 raised to power what? 14 minus 4k minus 4k plus 5 equals what? 3 raised to power what? 2k minus 2 minus 14 plus 4k. So if I'm to solve this further, that will become 3 raised to power what? 14 plus 5 minus 4k minus 4k is equals to what? 3 raised to power what? 2k plus 4k minus 2 minus 14. This one will cancel each other. Why? Because they have what? They have same base. Since they have same base, what do we do now? We'll solve this further by having 14 plus 5 minus 4k minus 4k is equals to what? 2k plus 4k minus 2 minus 14. So this one here is what? 19 minus 8k is equals to what? 6k minus 16. So if I'm to solve this now, I'll collect my like terms. When I collect my like terms, what do I have here? I have minus 8k minus 6k is equals to what? Minus 16 minus 19. So what do I have here? Minus 8k minus 6k, that become minus 14k is equals to what? Minus 35. Divide both sides by what? Minus 14 and what? Minus 14. So this will cancel this will cancel this. The minus here will also cancel each other. So what do we have here? My k is equals to what? 35 over 14. So if I'm to reduce this, that because my 7 here will give us what? 5, while my 7 here will give us what? 2. So we've been able to prove this according to the question using making our reasoning clear. We've already used algebra to prove that my k is equals to 5 over 2. So the next question, what was the next question? Says for my b, this is a. For my b said, hence find the sum to infinity of the geometric sequence. So for my sum to infinity, so I need to get my sequence back. I have 3 raised power what? 4k minus 5, comma 9 raised power what? 7 minus 2k, and 3 raised power what? 2k minus 2. Substitute the value of k is equals to 5 over 2 into the sequence. So if I have that now, this will now become 3 raised to the power of what? 4 open bracket what? 5 over 2 minus 5, comma 9 raised power what? 7 minus 2 open bracket 5 over 2, and 3 raised power what? 2 open bracket 5 over 2 minus 2. So this will cancel each other. So I have my 3 raised power what? 2 open bracket 5 minus 5, comma, this will cancel this. I have 9 raised power what? 7 minus 1 open bracket 5, comma 3 raised power what? This will cancel this. 1 open bracket 5 minus 2. So this will now become 3 raised power what? 10 minus 5, comma 9 raised power what? 7 minus 5, comma 3 raised power what? 3 raised power 5 minus 2. So if I'm to solve this further, what do I have here? I have it to now become 3. This is 3 raised power 5, comma 9 raised power 2, and 3 raised power what? 3 raised power 3. So my sequence will now become 243, comma 81, comma 27. So this is my sequence. So my A here, which is my T1, is equals to what? 243. While my T2 here, my T2 will now become what? 81. So how do I get? I need my common ratio to solve this. I need my common ratio to solve this. So recall that my common ratio is equals to what? T2 over T1. So my R is now equals to what? 81 over 243. So if you cancel this one out, that's 3. So my answer is what? 1 over 3. So I will now be applying the formula for sum to infinity. Sum to infinity, we have it as what? Sum to infinity equals what? A over 1 minus R. When I have that now, what will it be? I have my sum to infinity is equals to what? My A is 243 divided by what? 1 minus 1 over 3. I have this to become 243. Everything divided by what? This is 3. That's 3 minus 1. That's 243 over 2 over 3. So I have this to become 243 divided by 2 over 3. And my sum to infinity is equals to what? 243 multiplied by 3 over 2. So this will become 243 times 3 over 2. So this one will give us what? 729 over 2. This is my final answer. So we've been able to find the sum to infinity and prove that k is equals to 5 over 2. So if you have any question, As regards this, please kindly drop on the comment section below. Don't also forget to subscribe and like. Thank you. I'll see you next time. Bye.